The negative part is called the arc of approach. As a big class is recess. So the recess and the approach, if you add the recess and the approach, it's called the arc of action. And then this is the arc of the left, and then this is of course the angle. Then angle of action. Yeah. Okay. And then there's another one which is called the pressure angle. Now the pressure angle is a line, it's actually a line. The special configuration of the tooth, which are cut in delivery sa tooth this is called an how do we describe an envelope? Okay, so an envelope is the curve that is traced of an unextendable cord that is being unwrapped around okay, let us say you have a circle and then you wrap around a cord. Which is gini sa kainan ko so you have probably the end of your cord is here, and then you unwrap it. So what will happen here is so this is the end, and if you unwrap it, this is the end. So this is called the envelope. When I say profile of the envelope. Now, what is important here that chemistry is always a line, it's always tangent to the circle. So, property sa envelope is that anywhere ang position sa iyong contact ring, it will always be tangent to the circle. So, ang result niya is when you have to envelope the current contact, they will always their angle of action, meaning gana kanipon. So this is the contact niya. This is perpendicular. That is the line of action. And the line of action is the line where their forces are in that direction. Now, this line here is called the line of action. Now, if you trace that, when the two things are in contact, from here until there, they will follow this line. They will follow this line. Okay. So, and then it's called the so this is your this line is perpendicular to the line of sectors, and this is the line of action. The angle between is perpendicular to the line of centers. So this line of action is called the pressure angle. When I was teaching machine elements, I always emphasize because I know this is one important. Ako ginagawa one of my exams, they actually draw and input. There is a technical procedure of right? It is what will happen is that this guy so nice. And then we walk away from that. The anak orang itu, anak this is the movement. This is what there is on the day party. Okay, but that is just a background of the file. And what is important here is that all the actually always passes through the center instead. And that property makes the hair function properly. They will remain in that state. What I mean is, if you have to let's say, now, remember that the speed ratio is relative to the center of this section. Kung maulo ka din, just experience ka. Kung malayo niya siya, hinay niya ito yun kasi aking gaman. So, kung may anay, like this one, that is your radius and this is also your radius. You have a certain speed ratio. However, when you move this around, pag yung anin, is probably there will be a product radius anin will change. So probably there is a product. So probably ang radius anin now. So if you just make sagot sa reforma, just under Moyo, what will happen there is if you rotate it faster, your speed ratio will be varied. Kusog-kusog kayo, depende na sa radius. However, if you make it into an envelope, isang asa ng position sa ilang lata, parehas din na siya o speed ratio. So that is why we make the manufacturers of gears really have to take care of making the profile perfect, almost close to perfect. Okay, moment na siya smooth mo kaya ang iyong pagkana. Okay, so that is the basis why ang atong gear profile of the gear tooth is dili na siya sa konsalat. Kinahanglan nga hindi nga part sa pinili mo, nakakapag part sa pinili mo. So, probably, kasungkol sa contact na rin kami, pinili mo na siya, nakakapart. We've been making yung pares na bipon. Nakapag siya inulog. Okay? But these are all basics na siya sa paano, sa atong machine elements. And then there are general profiles of tape. Ang original was designed vertical, but later on, this standard, wala na po sa vertical tayo, became obsolete. So first important equation that I'm going to introduce to you is interference. That extension is found in 11.6, section 11.6, figure 11.7, or the paragraph. It is evident that the envelope cannot extend inward beyond the base circle for which it is generated. Hence, the pinion revolves counterclockwise. The first point of contact between the two. Okay, so what I'm trying to say here is, if you have two mating gears, okay, salon is however, for example, the number of teeth is less, ang mahitang is probably tulad dali kani dili sa kapon. So probably dili na mo dili na mo kayo. So you have to make it closer. Dili mo kapon na. So there is a certain portion from the mirror na siya. Dili na mo sa kayo. Dili ba kini? Dili na mo sa kayo kay. Bagay nga, no? So that is the meaning of the interference. The drawing is found in 11 and 7. Basically, ang wala na sa ikasabot nga, bagay ba? If you, kung hindi mo rin mo, bilaw mo rin mo, probably, hindi ko na siya makakala, hindi na mo salot mo sunod. So, ibon ka doon. Panoolin mo, bagay na mo. So, that is interference. Okay? There is an equation for that. Okay? So, ang equation is found in 11. And then interference in equilibrium. The equation is, by the way, see the figure now. 2 and P and G equals 4M and G plus M over time over P. P, by the way, is the pressure number. That's okay. Equation 11 has 3. H. So how do we use this? This is the equation wherein if you substitute, so probably when application will be is the pinion has the smallest number of feet. The pinion has the smallest number of feet. So what this equation is useful is to find the smallest number of feet of the pinion wherein there is no interference. Okay. Example, right? I will give an example. Nanti saya akan determine bahasa orang yang maksudnya biasa berbuat. Jadi bahasanya apa yang Kalau soal mereka berdaya, para jauh penuh, bingung kaya. Tidak ada, oleh opinion, dan building. And 14. And then have building. So, where do we get that now? So, let's look at the proportion of gears. That is table 11, that's one. Table 11, that's one. And you find the table? Now, okay. Now, what is M? What is M? M dere, ini siapa yang M? You look at this, no? This is another one. Addendum. So you look at addendum. Addendum for a 14 and a half year. Now that's a big one. 14 and a half year. Addendum. Degree 14 and a half degree year. Now, kung sa manangyayang pa addendum? 1/3. That is 1/3. That's addendum is 1/3. Okay. So basically, ang M&A on page 260, or you will find this in the formula. There is a paragraph there. There is a paragraph that says just below the figure 11-8, there is a paragraph. So can you read the paragraph? Let the addendum height, let the addendum height be expressed in terms of the diametral pitch, making the addendum equal to M/P. So if you look at that, addendum is actually addendum is M over theta. So kining M is actually the numerator, no? This fraction. Numerator of this fraction. So if you look at table, table niya, table 11 plus 1, ang alam nun niya is either 1 over p, 1 over p for 20, and for helical herringbone, 28 over p. So there are only two values for m. It's either 1 or 28. So for herringbone and helical, these are really sila Spur gears, no? Herringbone and helical, actually ang iyang gear, ang kaanak niya mga sa anak. So sa Spur gear, ang m is always 1. So m is always 1, meaning 1 is siya sa buhay. Okay, so if we try to look at this problem, you are going to determine the smallest number of days of the period if it is paired with a 62th gear. So 62th gear. So ano na yung paglahat? Ang pinion na ito is the alone number of days of the pinion. So number of days of the pinion squared plus 2 times number of days of the pinion, number of days of the gear is 60. And number of days of the gear, opinion equals 4. This time m is 1. And number of days of gear is 60 plus 1 over sine. The first angle here is 8 and a half degrees. Okay, there you go. This is basically quadratic equation in terms of the number of days. I'm going to write it again. Equation would be number of days of pinion squared plus 120. Number of days of pinion minus na lang ako balik sa likas. Kailangan na siya. If I go calculate this one, what is that? I go calculate 4. So, by quadratic equation, you can solve this now. 26.
55,726. 726.
So actually, there is no easy value. So it's already siya. Or 27. So the minimum number of things or opinion that will operate with a 62 gear for a full depth for given gear is 27. If you have 26, you will already have interference. Basically, already sa amuhan.
Kung ang decimal circle less than 5,
Okay, inangad.
kung admin ka sa
Sa kayo ka. Kung mag-out ka, it is already less than 5. So, pasaka ka sa sunod. Ay, kasi 26.1. Ang 26.1 may 1. Ang 26 degree.
so dapat masaya sa 26.1.
Yung ako ko, kanina.
The next is 7. Kung admin ka mo, kailangan
Awas, sirado din sa 26, wala din pa. Wala din. Okay. Okay. Strength of Spartans. Strength of Spartans. You look at figure 11-11. Yan yung mga sigas kaya magagamit. Pero ako kung figure sa sigas, sigaw. Hindi pa kayo gawin na kita, gawin na nakita ng sigaw. Okay. So let's look at the strength of Spartans. You will have a drawing there. You will have a drawing already. Profile of the game. Magkaalit siya. Ayun. Okay, you look at the figure. So you will notice on that figure. This is your base circle. This is your base circle. And next here. What is important here? Getting the bigger grade. side apart. Okay. So these are the forces that is acting on the surface of one of the pin. So this is the force that is coming from the driving pin. Yeah, this is the reaction. Now it's a reaction director. Now it's made up of two components, no? Or actually, the resultant area is in normal force, which is actually perpendicular to the surface. The surface, normal siya. However, it can be resolved into two components, where this one is the tangential and this one is the FR. So that one. FT and FR. Normal force is made up of two components, FT and FR. FT, transmitted force. Okay? A force transmitted. Actually, FR is radial towards the one. So what does it mean? Ang total force table is the normal, and you break it into two components. One is sama dengan tangent ang direction niya. Ang isa is towards the center. So this one is actually the most important force that is pushing the case to rotate. Para mutuyok siya. For this one, ang iya ng purpose is gadoot siya. So basically, kung madili mo kung ng case, kung dili mo kung ng mga gear, nasa lesson na diya, okay, mo sa pagkakas kung magulang na sila, they will separate because of this one. There is a radial force. Because dili siya isang complement tangential lang sila. Namin sa component ano yung dito. So that is why magulang na sila. Pero kini is the most important part, which is what we want. Nga mutuyok ni siya, drives the gas. So that is the transmitted force. So muna na sa ito. Ang kini profile na rin, kanyang profile shows the stress. So this part here, beyond that, wala na siya stress. Okay, kini manangin mo force. Beyond that, wala na stress. However, the ring, so you will notice, this is, ang force ani is bending man yan. Pagtunod na, your gear is like a cantilever. Jadi, ito. For this one, ito si cantilever. Ano po siya, so it's like a cantilever and being posed. So pero if you try to locate the concentration of the force, it is here. So naasa niya, ang figure when you drawing niya sa inyong libro is butang ang force direct. It says mas accurate niya ang gamit butang direct rather than direct. Wala kasi hindi mo nito taas. Okay? Pero muna siya sa mga in the figure, since the tone is like a cantilever, then what we are going to use for stress, strength of the gear, for stress, we are going to use the one more cantilever. This is called the Lewis equation. So, Lewis equation, this is for strength, The Lewis equation is ini. You will notice that nag-comment sa inyo na together FP, S, F, Y, over P na capital. That is the Lewis equation. That is found in the morning stress.
Equation 11-10.
11-10. S and Y over P. Inana siya niya sa inyong one. Sa inyong one. This is the X is the stress. S is the stress. Stress. While ini is the phase width. Phase width. Ang kalabon sa inyong one. This is your head. And that is your phase width. Ay, sorry. Sorry. Ang phase width dito. This is your head. So this is your phase width. Kapag sa inyong hipon. So F is your phase width. Nanagay sa mana. Then, of course, we know capital P, diameter H. Ang Y din mo is form factor. Form factor. Ang atong gamiton na is only capital Y. Capital Y na siya. Naman po yung form factor na small letter Y. But, ang gamit natin nila is para sila related na sila. Pero yung mga form factor are all related. It's like diametral pitch and circular pitch. Because later on, you will find out na ang form factor, mayroon po ka na Y and Y is equal to 5. Anak po siya. They're just like P and P is equal to 5. Pero sa atong equation lang, capital Y naman. So we are going to use the capital Y for the form factor. Okay, that is the first equation, Lewis equation. Now, this is assuming that the end of the spaghetti is just wala sa kalihok. And then the load is like a together siya, I think, inner load. So, together siya, na pinag-support niya. However, once we already use it as a gear, it is now rotating. And then we are now going to modify this Lewis equation. Okay, the first modification is found on 11 plus 2. Ft is equal to working stress. Lagyan mo sa phase width, form factor, over. Pero na-siya factor lagi. Multiply na rin. This is what is the appropriate use for this formula? Saman. Tanawan niya sa kwan. 11 plus 12. Lewis, 1 P is the physical velocity in feet per minute in this. 4 ordinary industrial gears. Nakita niyo? Operating at
2,000.
okay. So velocity is up to 2,000 feet per minute. Ako lang ito tayo formula nito, 11 plus 12. Eleven plus 12. Speed coordinate. Okay. Then there is another one. This time it is the Canadian y over but diagonal one way. It is 1 2 over 1 2 plus b. You have the next one. This is 11 and 13. Okay, velocities up to 4,000 feet per minute. And lastly, FP equal to SWFY over P, then 78 over 78 plus square root of B. This is 11 B. B. Precision gears, you know, about B over 4,000.
Precision gears,
So this one is, the first one is ordinary industrial, then this one is accurate pickup, and this one is precision gears. Okay, so muna siya ang mga equation. Then, there is a very important statement below that equation. Okay, okay, let's read. Okay. FT. How do we determine FT? FT is equal to 33,000 HP 133. 50 man siya auto 50,000, diba?
Yes, sir.
Ay nga naman.
Foot pound per minute.
Okay. Kaya ang atong velocity is per minute siya. Okay. Definition. So that is for 11 and 15. Can you see? Nanin kita ninyo? Wala eh. Isulat na po din. FS, wala. Wala. Okay. But anyway, we will find it later. Another say FS. Okay, and finally, so what is your mga formulas, no? This is, okay, to find if we have the horsepower transmitted and the velocity, we can find the FT. Then once we find the FT, we want to reach the method. Hey, and there's an important statement there below. These equations of gears operating under steady load conditions when operating more than 10 hours subjected to shock. Okay, irreversible contention loads will be modified according to factors in 11 plus 4. So we have to modify this according to a table in 11 plus 4. And then so that is one statement there. And then the next one is, for any set of operating conditions, there are many combinations of peaks. By the way, when peaks is peaks or diametral peaks. Kanang capital P. Kung yung peaks is already one. Unless nice circular peaks, then it's not diametral peaks. You know, peaks for that, then it's already diametral peaks. Okay, so for any set of operating conditions, there are many combinations of pits. This is the meaning here is the diametral pits, the phase width, and the number of pits that will satisfy the Lewis equation. Now the Lewis equation. So diametral pits, phase width, and Number of teeth. Okay. So the number of teeth, mukha na niya siya kining y. Y. That is the form factor that will come into place. Okay. Ang form factor will depend on the number of teeth. Okay. However, a well-proportioned ear, this is important. Ang balance ng ginagawa. Proportion. Yes. Face width. Ako na ba na-example sa face width is from 8 over 3 to 1.5. 12.5 over 2. Approximately. So, once you are within, it is well proportioned. So, currently, error dito ang mga once you are within, it is well proportioned. Meaning, your gear is actually limitation nipis. A well proportioned gear is something like this is your gear ako yung diameter. Sinama na iyan pa. Iyan kalapon nyo rin. Should also be well proportioned. So that is why it is the face width. The thickness of it is 8 over PMP is the diameter pitch. By the way, once the diameter pitch is number of teeth mo na siya per inch of diameter. So if you try to evaluate that, if you increase the diameter pitch, what would you visualize in the teeth? Number of teeth or something like that? Per inch of diameter na siya. So, kung sa may meta mo sa itong gear, if your diameter pitch will increase, ang format sa itong pagka, the way you look at the teeth, ang profile niya. So, if you just take the diameter constant, so sa man ang kuwan, ang increase is the number of, aron mo increase yung diameter pitch, you increase the number of teeth. So, mo increase yung number of teeth for the same diameter, sa may makita niyo sa mga nito. Pino siya, no? Kaya mulakan man siya. Basically, that is the meaning of diameter pitch. No? Relative to the diameter, tagagag na rin kung ito pino siya. While if your diameter pitch is gamay, then gamay na number of teeth na dagko. Okay, so, under the standard, by the way, for diameter pitch, there is a standard value of relation of sa good sa rock. Sa kukuha na. Diameter pitch. I think in a right proportional for the table. Okay. 11 is 1. Look at table 11 is 1. Diameter pitch P and N is number of teeth. So, unsa man? Kani siya, diameter pitch ka ng sentence. Diameter pitch varies by increment of 1/4, 1 to 2. So, na-apply, you start with 1, okay, wala pa sa ikuha. You siya from 1 to 2. From 1 to 2, so equal diameter pitch could be 1, 1 and 1/4, 1 and a half, 1 and 3/4, 2. From 2, 2 and a half, 3, 3 and a half, 4, 4 and a half, 5. No? Then from 5, 6, 7, 8, 9, 10, 11, 12. From 12, 14, 16. Okay, so muna siya yung mga standard dili ka dili ka diameter results na tigo ka na ang mga values. So, sa lain na rin. Because we will have an example. Takuha na lang, no? Kami, may example din. We will try to, sa next meeting na lang din, meeting mo dito na. I'm just preparing the equations na importante nga itong gamitin. Okay, wala na. Okay, I think, hindi ko kayo profile ni gamay na kayo sulat ni. Ay, hindi ko na yung nasa room na rin. So, mas ganang ako nga na yung mga interaction. Pero we will have an example and then we will further elaborate and discuss in more details kung paano mga plaka na discuss dito. There is a problem na okay, isa may nagkaroon sa attendance ako na katong kuan on inyong kamera tayo mag-screenshot na ba ko? Mag-screenshot ko.